Hello everyone, welcome back to my channel Decode Data with SKD. Let me ask you something. Do you really feel that minimization problem in LP is confusing? And if your answer is yes, trust me, you are not alone. Most of the students feel confident with maximization problem, but the time they get minimization problem, they are confused and have different questions in their mind, like how to select the common area, which corner point should we choose, is the approach different. So different type of questions they used to have. Trust me, minimization problem is not at all difficult. In fact, once you understand the logic, they become one of the easiest and most scoring part of the LP. In this video of mine, I'll show you step by step how to solve minimization problem with the help of graphical method. And trust me, this works perfectly for your exam problems. Stay with me till the end, because in next 10 minutes you will able to understand how to solve graphical minimization problem without memorizing anything. You need not to memorize, you will understand, right? So let's start and try to understand how to solve the minimization problem in linear programming with the help of graphical method. Fine. As usual, when we go for linear programming, we have to formulate the model first. So this is what you can see a model. We have two different variables, objective function with minimization, and we have three constraints plus two non-negative constraints, right? Now, the first step that we have to go for is to convert these constraints, whatever the constraints we have right now, we have three constraints, into equality, right? How we will convert? We'll simply remove this sign of greater than equal to and just put the equal sign, right? So we have kept the equal sign for all three cases. So now it's converted into equality. Simple. This is what the equation 1, this is what the equation 2, or this. So we'll say is a constraint 1, constraint 2, and constraint 3. Now we have three constraints with equality condition. Now the next step is to find the line coordinates. How we will find the line coordinates? Same way, same method. We have to go for x1 as 0, right? So let's say the first equation is 5x1 plus x2 is equal to 10, right? So if I'll put x1 is equal to 0, what will happen? x2 will be 10, right? And when I'll put x2 is equal to 0, x1 will be, this will be, so x1 will be 2, right? Clear. So now we have a coordinate for first line with the help of first equation. So with this help of second equation, we'll find these coordinate in the same manner. We'll put the value of x1, we'll get 6. We'll put the value of x2, we'll put 6 in equation 2, right? In this equation we have to, right? Then equation 3, this is what the equation 3 we have. So in equation 3 again, we'll put x1 is equal to 0, so we'll get x2 is equal to 2. And when we'll put x2 is equal to 0, we'll get x1 is equal to 12, right? So now we have three constraints, and based on three constraints, we have three different coordinates. So let's see what are the different coordinates we have. The first coordinate, the line coordinates are, from first equation we have 2 and 10, x and x1 and x2. Second, 6 and 6, right? And the third one is 12 and 3. 12 and 3. So now we have three constraints. The time you get three constraint, or the time you'll get line coordinate, whether it is with the three help of three constraint, or with the help of two constraint, or with the help of four constraint. Now the next step is draw the graph, right? So let's draw the graph. Now this is what your model function, and this is what are the coordinates we have calculated, right? Now in the graph, now let's take the coordinate for first. equation, sorry, first line. Now 2 and 10. So x1 is 2. Let's say this is x1 and this is x2. X1 is 2 and x2 is 10. So we just join these two with the help of a straight line, right? Then with the help of equation 2, we have 6x1 and 6x2. So we will join this. And with the help of equation 3, we have 12x1 and 3x2. So we will join this. Now, with the help of three equation, we have three lines, coordinate for three lines, and now we have three different lines. All the lines are drawn, right? Uh, if you see, this is the first line, this is the second, and this is the third one, right? Now, when the lines are drawn on the graph, the next step is find the common area. So what we do with for the common area, we'll move down to the constraint, right, and check the sign they have. So the first line is having a sign of greater than equal to. As I already told you, when the sign is greater than equal to, we will put the arrow towards outer side, right? Outer side, towards this side. And when we have this sign as less than equal to, we'll put the arrow towards lower side, towards 0, right? This is what you have to basically remember, because this is the point where normally people do errors, right? So this is what you have to check, right? So because the first equation is having a greater than sign, so I have a arrow towards outer side. Then move on to the second one. Again, this is having a greater than sign, so I'll have a arrow towards outer side. And in the third equation, we have a greater than sign, and this is what the third line. So we'll have a arrow towards outer side. Now, when we have a arrow, this arrow will tell us what is the common area. So now in this case, the common area is starting. This is what the common area, right? This is all is the common area above this line, the this line, right? From this line, above this line, we have a common area, right? Now, when we have a common area, now the next job is to find the coordinate of the intersection point of the common area, right? So this is the first coordinate we have, this is the second coordinate we have, this is the third coordinate we have, and this is the fourth coordinate. So now with help of three constraints, we have three lines and four different coordinates in common area, right? So now when we have the coordinate, we'll go for the coordinate value. So the first one will be 0 and 10, second one will be 1 and 5. So 1 will be towards this, x is 1, and this is, if you draw the line, this is 5. So 1 and 5. Same we have 4 and 2, and this is we have 12 and 0. Now four coordinates are with you. Now once we have all four coordinates, the 0, 10, 1, 5, 4, 2, and 12, 0. Now the next and the last step is take the objective function, right? Put all the coordinates in the objective function. So this is what the objective function is, and this is the first coordinate, 0 and 10. So when I'll put 0, x1, and in place of x2, we'll put 10, this will become 0, and this will become 20. So final answer will be 20, right? In case of this, when I'll put x1 is 5, 1, and sorry, x2 is 5, this will be 3, and this will be 10. So total will be 30. In this case, when I'll put x1 is 4 and x2 is 2, right? This will be 12 and this will be 2. Sorry, this will be 2, so it will be 4. So this will be 16. And in this case, when I'll put x1 is 12 and x2 is 0, this will be 36 and this will be 0. So 36 is the right. Now, because this is the case of minimization and we have four options in front of us, I will choose the minimum option out of it, right? And minimum option is 13. So 13 is basically the final solution and the coordinates are 1 and 5. Now what these coordinates indicate? Coordinates indicate that if you produce 1 unit of x1, 1 unit of x1, and if you produce 5 unit of x2, the total cost incurred in case of this one will be 13, the minimum cost, right? So this is the minimum cost you can go for giving subject to the constraint given, and in this case you have to produce 1 unit of x1 and 5 unit of x2, right? So this is what basically the minimization with graphical solution, right? You need not to basically go for this, because in this I mentioned wrong unit, so don't consider this. Now hope you are very much clear with how to solve minimization. In case of any query that you have, please share your query in comment box. I will try to reply as soon as possible. I also request you to please like this video, share this video with your friends, your colleagues, your student of different colleges and professionals, and also subscribe to my channel Decode Data with SKD, so that you will get all future videos on time. Till then, thank you for watching. Have a nice day.